Okay, so in this video we're going to have a look at some exponential functions, and what we're going to do first is we're actually going to be looking at this exponential function, which is f of x is equal to 2 to the power of x. Now, what we notice about an exponential graph is that if we were to take tangents all the way along, we can notice that the graph is increasing at an increasing rate, okay? And so if we were to sketch the derivative function on top of the gradient of the original function, you'll notice that they look almost exactly the same, except they differ of a factor, and that factor is 0.693. So what we can say is that, well, if we have a function that is equal to 2 to the power of x, then the derivative of that function is equal to what was it on the graph? It said 0.693 times 2 to the power of x. So that's the derivative. If we were to have a look at another function, okay, let's say we wanted to try 3 to the power of x, okay, so again, it's another exponential function that looks like this. And if we were to graph the derivative function against this function, you'll notice that this time the derivative function is a bit bigger than the original function, okay? And so we notice that that one's at 1.099. So what we could say is if we have another function, the derivative of that one is equal to, it was 1.099 times 3 to the power of x. Okay, so basically what we're saying is that the derivative of exponential functions are just themselves multiplied by a scale. Now, there must be one of the functions, or one of these exponential functions, where the derivative of that function is actually equal to the function itself, so where it's exactly on top of that. And we can pretty much get an estimation by doing essentially what is called a, I forget the name of it, but essentially by changing the number and getting closer and closer, okay? And so if it becomes too big, then you just go back and then, halve it. So it's got to be between 2 and 3, okay? Because we know that 2 is small, so that if we keep going up, and 3 is too big. So what we'll do is we'll halve of 3, well, halfway between 2 and 3 is 2.5. You notice that 2.5 is a bit too, it's not quite big enough yet, so try 2.6. 2.6 is not enough, 2.7, and 2.7 looks pretty much spot on, but there is a little bit of a gap, and what we can do is we can say, well, 2.8 is too big, so 2.71, 2.72, 2.72 is too big, and so on and so forth. And we essentially get to this number, and that number that we get to is called Euler's number, and it's known as E. And this value of E approximates to 2.711828, okay? And so essentially what that is it's referring to the function, or the exponential function, in which its derivative is exactly the same. So if I was to write it over here, what it's saying is if we have another function, h of x, if we had the function, so if I was to put in e to the power of x, which e is approximately equal to 2.711828, blah, 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 okay, then the derivative of that function is itself, or 1 times itself. And this is really cool because it actually helps us a lot with exponentials in general. So, just like pi, Euler's number E is a irrational number. And if we differentiate e to the power of x, we end up with just e to the power of x. Okay. So your calculators actually have a button E, and it allows you to do things with it. So if we put e to the power of 1 into the calculator, it pops up this 2.71828 blah blah blah. Looks like my approximation was a little bit different to the other one, but anyway, the value here is what's known as E, and essentially we can use our calculator to come up with different values of E for these different values on the exponential. So for example, if I wanted to work out what e to the power of 2 is, or what the exponential function of e is at 2, so that's it up here. So 7.389, what I can do is I can put e to the power of 2 into this, and it will give me that value, okay? And so that's pretty much what E is and what we want to know about E. Okay, and we can always use our calculator to do approximations for E. So in most situations, when we care about E, is either to do with exponential functions, or again to look at the inverses of exponential functions, which are logarithms. Okay, so let's have a look at some quick examples before we finish off this video. So in this one, we've just got some easy evaluation questions. So we're going to evaluate correct to two decimal places. So essentially, we're just going to use our calculator for this. So we're going to start off with E. So if we press Shift, and you can see that it's above this ln button, e to the power of 1.5. Well, that gives us A is equal to 4.48, correct to one decimal place. E to the power of -2. So we're just going to replace the E with -2. And that's going to give us 0.13. Oh, sorry, 14, not 13, to two decimal places. 14. Now, next one, two lots of E to the power of 0.3. Okay, so again, we're just going to put it straight in. It's going to give us 2.70. If we round that to two decimal places. Okay, next one is 1 over E to the power of 3, which is equal to 0.05. So D gives us 0.05. And lastly, E is going to give us -3 lots of E to the power of -3.1, and that one is minus 0.14. Minus 0.14. Okay, so that's pretty much what we're going to be talking about at E to begin with. In our next video, we're going to have a look at the transformations of this exponential function. So I'll see you guys in the next one.